Okay, brilliant. So, once again, welcome to our chemistry topic. Mole as a concept. Mole concept. Mole concept. Mole concept. Okay. So, before we begin, we kindly need you to subscribe to us if you have not done that. And please try and make good use of the playlist. Okay? Go to us and go to the playlist. We've arranged all the videos there categorically according to subjects. Now, let's go. So there is a topic designed for pure chemistry students, right? We have the same thing in integrated science, but there is pure chemistry mole concept. Now, what is the mole? It is an amount of substance which contains as many elementary particles or entities as there are atoms in 12 grams of carbon 12. So what does it mean? It means when you break carbon 12, not carbon 14 or carbon 13, the isotopes of it, just carbon 12, and you break it, the number of entities you see inside is equivalent to what we call a mole. That is why the definition is linked to what the carbon 12. Are you okay? So the amount of substance, which contains as many elementary particles or entities as there are atoms. That's as there are some atoms in 12 grams of carbon 12. So the number of atoms you see in 12 grams of carbon 12 constitutes what we call a mole. So if you don't know what a mole is, just get 12 grams, not 15 or 17 grams. Just weigh 12 grams of the carbon 12. What you see inside is equivalent to what? A mole. SI unit for mole is mole. The unit is mole, MOL. The symbol is MOL. So coincidentally, look at that. The symbol is this. It's a symbol. You see, the symbol for kilogram is kg. The symbol for mole is just MOL. The symbol appears to be the Y, right? So take care. So if you see MOL, it's a symbol form. You see MOL is the unit spelled. Like you try to spell watts, W-A-T-T, and I using a symbol for watt, capital W. Are you okay? Avogadro's constant. It is a number of elementary particles or entities in one mole of a substance. The unit is per mole. Molar mass. It is a mass of 1 mole of a substance. The unit is gram per mole. Relationship between mole, number of entities, and Avogadro. N equals small n by L. So there is a number of entities. It stands for molecules, atoms, ions. So when they say find the number of molecules, we are talking about this. Find the number of ions, we are talking about this. Find the number of electrons, we are talking about this. Find the number of atoms, we are talking about this. Find the number of moles, it's just this moment. Are you okay? So don't confuse when you get it. Moles, so the short form of molecules, it's just coincidence. Now it's Avogadro's constant. Relationship between mole mass and molar mass, that is it. Number of moles or amount of substance given by the mass and the molar mass. Relationship between mole volume and molar volume is 2 minus. There is volume, there is molar volume. That is it. Application. How many molecules? You can see that we are trying to talk about the capital N. You see that? I want to say how many moles, then we are talking about a small n. So how many molecules are present in this? So the whole of this is just a molecule. Are you okay? I've asked me atoms, counting nitrogen and counting hydrogen. Just a molecule. This is right? So how many molecules here? So I have n equals n by L. That's the I. Now the number of moles, that's 1.5 by what? Avogadro. Now compute. And the next one is also what? N equals small n by L. And 0.2 by what? Avogadro. Compute. Molecules, because I was asked to find molecules, okay? That's the units. Molecules. Okay. Okay, so be very careful when they ask you to find number of entities. Here, I was asked to do molecules. Now, what about here? How many ions are present in 0.6 mole of this? How many ions? Whether cations or anions, that's what they're asking. I can't tell. If it were to be how many molecules, I would have just multiplied this number by Avogadro, and that is all right. Now, how many ions? So I think here, the Avogadro constant is given here. So how many ions? So this is what it is. Now, this, the whole of this can be a molecule, right? Now they say ions, so you have to break open. So that's calcium 2 plus, right? Plus 2 chlorine minus. Do you see that? Okay, so how many ions are present here? I can see I have 1 ion. I have 2 ions here. Do you believe that? Cool. How many ions? That is, you see, there is just 1. There is just 2 ions, right? That's 2 minus that. 2. Just 1. So, okay, this way. So, there is just 1 ion, 1, just 1 cation, okay? This one, we have 2 of them. Are you okay? So, that's just 1. So, there is just 1. Here, we have 2 of these chlorine minus 2, okay? So, it means that 1 mole of calcium chloride. Why do we say 1 mole? Can't you see it's just 1? Are you okay? So 1 mole of calcium chloride produces 3 ions. You agree? So just 1 mole, it produces 1, 2, so 3 ions. So my number of moles will be 0.3 by 3. 0.6 by 3, okay? Now what's the answer here? 1.8 moles. Then? 1.8 moles. 1.8 moles. So if I use this, I've used symbol, okay? Now, how many ions? How many ions? Are they not looking for number of entities, capital N? So number of entities is this, by that, right? So there's 1.8 by Avogadro. Confused? 1.08 times 10 to the power 20. How many ions? So what? Ions. Are you okay? That's also another aspect. Calculate the number of molecules containing 0.6 mole of hydrogen sulfur H2S. Molecule. That is what it is, right? Good. Solution. Number of molecules, entities, right? 0.6 or just that. So, Avogadro. 1.2 molecules. That's it. So number of molecules. So you leave your answer in what? Molecules. Okay. It's 3.6. 3.6. Mira, the number of atoms of H and S present in this. You are asking us to find the number of atoms in this. I have to break down the whole thing, right? Or associate it first. This way. So I have 2 of this, and I have S2 minus just 1. You see that? So how many atoms do we have here? We have 3 atoms here, right? We have 2 of this, and we have just 1 of the sulfur. So the number of atoms of each. So let's look at each atoms. Right? So my number of moles was 0.6. Right? By 2. Well, we have 2 of each atoms. Are you okay? Now let's look at S. So the number of atoms. So we'll have capital N by L. So small n is 1.2 by the Avogadro.
7.224 times 10 to the power 20.
Okay. Atoms. Very specific. Good. Now let's go for sulfur atoms. Okay, here. How many of the sulfur do we have? Just one. Now you were told that the number of atoms of each is present in this. So it is just 0.6 by just one of it. And when you get into those two, that is why I said 0.6 by just two of it. Are you okay? So my number is still 0.6 by just one of that, okay? It will still give me what? 0.62. Now number of entities and 0.6 by Avogadro.
0.612 times 10 to the power 23.
23 what? Atoms. Okay. Please, I hope you're okay with this question, right? The difference between this question and this question is the same. Before I get the number of ions, I have to break up. Just I have to break up and separate them into their isolated gaseous ions apart, right? Before I also see the number of atoms, I still need to break. Remember, it is an atom which forms the ion. That's similar. Good. How many atoms of sodium, Eddie, are present in this? How many atoms of sodium are present in this? Remember, our target is just sodium, not this, okay? So we have to open them up and select just sodium, okay? Good. Let's go. You agree? Yes, so it's this like this, okay? Yesterday was here. You see, this was the actual water during the preparation. Interchange. You see that? The one was not written, okay? That's still 4. But at the end of the day, if you are still breaking them, you still look like this, okay? Are you okay now? Similarly, you have Mg2 plus Cl and you see you interchange the charges, right? And you get it. Okay, you don't indicate the one. It doesn't mean that at the end of the day, if you see it's Mg2 plus, then you can't say it's 2 chlorine still. That's what happened, right? It's still for him, right? That is how the presentation should look like. Are you okay? You can't say this thing here, so this thing will not be here. So okay. Now let's go. So how many of these are present in this? It means this, one whole of this contains this, right? Okay. Then 0.025 by 3 of sodium, right? By 3 moles of sodium. Are you okay? So so that is the quantity of sodium I have here. Are you okay now? Now, how many atoms? 0.075 by what? Avogadro.
4.515 times 10 to the power 23.
Now, let's look at how we find molar masses of substances, right? The molar mass is defined as the mass of one mole of a substance. Your mass, my mass, her mass constitutes what we call what? The molar mass, right? Now let's look at the molar mass of HCl. The first one, molar mass of HCl. We have what we call H is what? Chlorine is what? 35.5. We're going to form what? 36.5 gram slash what? Mole. Here is the molar mass of HCl. Next. Now let's look at molar mass of H2SO4. Okay? Molar mass, using the representation of H2SO4. H is 1. The mass is 1. But it appears twice. You see that? Plus sulfur, that is what? 16. Plus plus oxygen. It comes 4 times by what? 60. Here is 2 plus 32 plus what? 60 by what? 64. 98 grams per mole. You see, when you bring this pen, then you don't bring your slash, right? So that is how we find molar masses. So, okay, let's look at our next application here. If the molar mass of copper sulfate plus X hydrate is 250, determine the water of crystallization, X. Okay, so I need to get the molar mass of this stuff here. Molar mass of this. Okay, let's go. So copper is 64, plus sulfur 32, plus oxygen 4 times. Are you okay? Now this thing here is still plus. Now watch. Yeah, because it's molar mass, we are still adding, right? So that's it. So X out here. We have what? We have here 2 by 1. You agree? Plus what? 16. Now there is 64 plus 32. That's what? 64 again. Okay. So there is 2. Let's see. There is 2 plus 8. That's 18, right? Are you okay? Okay. So there is 64. Okay, put the numbers together. 160. I remember, we were told something here that the molar mass of this is what? 250, right? So we believe it's 250. Are you okay? Okay, we're given. So we have 250 equals what? 160 plus 18x. You see that? So there is algebra. So the water crystallization is 5. What can hydrate this gaseous category is 5. So copper sulfate pentam hydrate. Okay.